Dr. Nguyen joined the School of Applied Computational Sciences as an assistant professor of computer science and data science in September of 2021. His research focuses on accelerating scientific computing and advancing data mining and machine learning techniques. His recent work on algorithms for context-aware forecasting includes computer vision, natural language processing, time series analysis, and anomaly detection. Potential applications are developing models and algorithms that incorporate community knowledge for strategic planning in smart city, urban informatics, disaster resilience, or healthcare settings. Dr. Nguyen has presented and published research work in popular journals as well as conferences such as IEEE Transactions on Big Data, IEEE International Conference on Big Data, and IEEE International Conference on Advances in Social Network Analysis and Mining, as well as Computer Software and Applications Conference. Dr. Nguyen was previously a lecturer at the School of Engineering at Texas Tech University. Before his PhD and academic career, he had extensive experience in software system development, project management, and team management at both international and local companies in Vietnam. So welcome, Dr. Long, and feel free to share your screen and we'll go ahead with your presentation.
Okay, yeah, thank you for the introduction. So let me share my screen and okay. Right, so let me redo it. Okay, perfect. So do you see my screen now?
Yes.
Okay, thank you. Good afternoon, everyone. So thank you for having me in the workshop. And in this talk, I like to discuss some potential from innovation and emerging technologies in order to enhance public health. I will go through a brief introduction, and then I will discuss two major sources of data that bring new insight to public health. One is from social media, and the second is from wearable data. If the time allows, I will discuss one of our recent work, a pilot project called Emotional Health and Climate Change Related Strategy Extraction from Social Media. This one is also exciting, and I like to share with in the workshop and for potential of collaboration. And at the end is my discussion of the work as well as the acknowledgement. So let's look at how two sources of data, social media and wearable influence to the public health. Usually people discuss the health issue with their healthcare provider, but that's not always the case because there are instances that people don't have time to go there, or potentially they have less trust from the healthcare provider, but they do have their own instinct to search for similarity or similar people who have experienced the same issue of the health problem, and then they share over social network, and then they find a match, and there is potential way for them to help themselves without going to the healthcare provider. On the other hand, wearable data nowadays is very available everywhere, and it's shared on the internet, and the people also utilize these wearable data in order to measure their wellness. So two of these sources of information have introduced a new way to look at public health that I will discuss in the following research work. So for example, here is the potential from social media and wearable, which is the individual wellness monitoring, biologic monitoring and surveillance program, or any communication surveillance regarding health messages. For example, a new vaccine approved, and what are the reaction from population, or any health intervention. As I said, people interact with each other over social network in order to find out how to solve their own case. It facilitates health-related research and any social support in online communities. You can see this in one of the research here. So the first one I like to discuss is using social media in order to help relapse prevention, opioid relapse prevention. And you can see opioid uses, it happen across United States. On the right side, it shows the heat map. In most of the state, so many cases of drug overdose in USA. And with opioid, usually it helps with the pain relief. However, people abuse that in order to make them happy, and it causes addiction afterwards. So we have to agree that addiction, what it means is it's a chronic and relapsing disease. People cannot stop using that. So the motivation of this work behind is with 1.2 million people had opioid use disorder in the United States, or 11.4 million people misuse of the prescription for their own personal interest, and more than 42,000 people die through overdose with opioid. So can we use technologies in order to help people better visualize and understand the opioid epidemic, or potentially detect the opioid relapse and explore any potential reason behind the addiction of it? Before we get into this opioid treatment, we need to know that usually people, healthcare provider provide two phases, two-step process in order to rescue this kind of issue. The first is stop using that, or withdrawal or detoxification of it. So people use some small device attached to the ear in order to send electrical pulse to stimulate the brain nerve in order to stop the patient from the demanding of using that. And the next step is more challenging because it's lifelong process, which is relapse prevention. Once people stop using that, it will happen sometimes throughout their life. They have the demand to use that again. And whenever they use it again, they tend to use more amount of opioid, and it leads to overdose and cause the issue. So relapse prevention is a major step, and it's a lifelong process. And people, traditionally people usually gather together and discuss, share their story, how they can overcome it, or thus share their any issues in life in order to overcome any stressing problems, any issue, so that they don't have to look for opioid. But that's not always the case nowadays with digital platform and how we can utilize that. So here, the rehabilitation process. We must admit with each other that the relapse is inevitable part of the rehabilitation process. And therefore, accurate relapse prediction combined with support from families or any colleges, members of friends, relatives, can postpone it or prevent it. And our goal is to early detect the potential of relapse so that the yellow part in their lifetime. So the blue is a clean process. That means they are doing well. And at the time they will find opioid to reuse again, that the relapse time. And our goal is to make this relapse period shorter, just because we don't want them to use that for a long time, and it may happen with overdose. So again, we don't look for a complete solution of it, but we want to compress the time of using that. So that's how we tackle this problem. So in order to look at this issue, we go over Reddit with a number of groups discuss about this issue. Opiate group, opiate recoveries, or drug group. These are the three major groups that bring a lot of potential. People make their own messages and comments in order to either encourage each other how to overcome it, or there are also other people who share their story so that other people may be influenced by their story. The data I collected through the group, and then some of keyword based like OC or Xanax or Dove. These are unique keyword represent for opioid usage. So overall, we have the total is about, I think, for more than 100,000 of messages, and it fall into different category as shown in the table on the right side here. And the first step is to look at some brief word cloud to see what kind of wording people use with respect to each emotion category in the group. So what I mean here is the messages may have emotion with it. So we categorize into 10 emotion category: the anger, anticipation, disgust, fear, and joy, and so on. And then make the word cloud over each of the category of the emotion. So you can see that many of the bad word uses being used with negative emotion, but the positive one provides some helpful messages from staying clean, friend, doctor, and so on. So this gives us some idea to look for what kind of issue happening from the emotion aspect. And then we go into word correlation. So what it means is we bring the word together with the correlated word together. And in this case, we can see that many of the detoxification process, or we can also see file here with connected with OC, opiate, and so on. So that means there are people discussing withdrawal symptoms, or there are doctor discussing some painkiller or any pain issue. But here is how I drill down so that we can take a closer look, because that a little bit messy. So when we look into it closer, we can see that they are supporting comment, for example, here from doctor saying that it takes months for the treatment. So somebody also say, hey, need to stay clean from benzo. So somebody found drug starts long time ago. So people share their story, and the withdrawal here, it takes days or long for it. And another way we look at this is the interaction among people in that social network. So we look at one individual as example here with the user Lunto 12, and then many of the command interact with this person commands. And we found that many of them stay clean or try to stay clean. And then also many of them still addicted. So there are two channels of interaction. One going from the people who try to stay clean and other from addicted group. And then with this idea, we bring into one of potential is if the connection has a lot of positive comments, or what I mean is people from the clean community, it most likely the person will stay clean. On the other hand, if it comes from different, from the addicted group, then it most likely the person would be addicted. So that's how we try to encode such information. And then we bring in something called sentiment images. So as said, we have 10 category of the emotion. And each of the emotion here is an average of 3 posted. So that the color, the brighter color represent some emotion, and then the dark color represent no emotion in that category. The influence or the network earlier called the influence from one person to other, you also incorporated as the second channel. So usually we have red, green, blue, but in this case we have emotion and the influence. So now we have to move forward. In order to do this, first we need to ask the patient, the individual, whether that is an addict or not. And then whether the person is recovering, seeking or not. And if it an yes again, then now is a process of relapse prediction. So we have to filter out such information in order to have our finalized data, in order to have relapse prediction data set. And in this case, we try with some traditional algorithm in order to classify whether it addict or not, and then whether it recovering, seeking. Usually with the addict or non-addict, people confess themselves, so it also easy to find out. But if we encode it to SVM, and the algorithm also work very well in this case. And the next step, once we have the data set, we go with generative adversarial neural network. In this case, we know that GAN is very good in generating very beautiful and perfect images. And therefore, we utilize it with our sentiment images in order to throw it in with the discriminator of the generative adversarial network. And we have the noise as in the part of generator in order to classify whether this is a fake data, this is relapse and non-relapse data. So with the use of noise, it helps to improve the generalization of the algorithm. So overall, we can see it like this. The noise go into the generator and then go to a bunch of encoding with convolutional neural network, multi-channel, and then it have the final output is a sentiment image. And with the discriminator, it will try to classify this image, whether it has a 3 probability, it fake, it real, or it relapse or it non-relapse. So it turned out that with GAN, overall accuracy and F1 score, it has better performance compared with other traditional algorithm. So the finding here is the emotion is actually play a very important role in this. We found that about 72% of the images produced, it has a negative and joy that impact to their relapse and non-relapse behavior. So this work is published in Amsterdam conference. This is a popular international conference on advances in social network analysis and mining. So the next one I like to discuss here is about using wearable data. So earlier it was a social media platform. So go back a little bit with COVID-19. So this is quite familiar picture if you usually look at WHO website. WHO report positive, negative cases or death due to COVID worldwide. And we can see this with in United States, 1.2 million deaths up until I think December 2023. So how, and we still remember in the past, hospital is what it run out of resources in order to deal with COVID patient. So how can we use technology in order to support this? We come into an idea, which is, so why don't we let the COVID-19 patient stay at home in some way, and then we have a remote communication with hospital in order to reduce to optimize hospital resources. Initially, this happened in my home country too. Everyone who is positive will immediately be hospitalized. It makes the hospital run out of resources very quickly. And of course, I know nowadays we have a vaccine. The COVID is still out there a little bit, but I consider as a way. But this proposed solution would be very helpful. So we try to utilize home treatment, and then only hospitalize if it required. And of course, in order to do so, we need to be sure some of the technical behind what need to be done first. And obviously, we must be able to classify the patient into the stages of the disease. We can't let the severe patient stay at home because there are no advanced equipment in order to monitor or provide support for the patient. And if it's a mild case, then obviously it has potential to let the patient stay at home on their own. So our solution in this problem is to classify the patient with their disease stages. There are 3 research questions in this work. Can we build an ML model to classify or predict the COVID-19 stages, identify whether the patient will move forward with severe case or going to be a mild case? And then what are the factors influence to the severity of the patient? And what signs signify the recovery or the deterioration of the COVID-19 patient? So the data set we look into is a well-theory data. This is a multivariate data set, and it has about 186 COVID-19 patients that include vitals, patient demographic, sleeping pattern, heart rate variability information. And then there are stages classified into 4 stages: mild cases, moderate, severe, and recovery cases. So if people who are in severe state, this is the red signal we need to care about. Mild and recovery is something that can be at home. Moderate is something considerable for either at home or moving into the hospital. The important part of this one is after doing exploration of the data, we found that heart rate variability is critical in the COVID-19 disease. So we look into this more deeply by having the lag difference of it, which is the rest rate of the heart. So that means how much time our heart stop beating until it beat again. And this, the unit is in millisecond. So it's very small amount of data, small amount of time. The second one is the absolute deviation from the mean. And then some other statistical numeric data include the variance, the skewness, the curve, max mean, and so on. These statistical features had long been researched and treated as important feature for the time series learning. So of course, we go through some pre-processing for the time series for the because it's a variable data, and we mean max normalization. So remember, we have two types of information there. The attribute stream. So what I mean, the attribute as like demographic, for example. We have temporal stream that is monitoring vitals of the patient, especially the heart rate variability or the rest rate of the heart. So the two stream of information make sense to design some network like this. With temporal stream, it is much better to deal with long short-term memory network because it's already popular to deal with long term dependency. And the second one is traditional dense neural network where it fully connected layers connect with each other. So the LSTM combined with the DNN here, and it makes the classification of the state of the patient. In this case, the DNN is a 5 fully connected layers with 1234 of neurons. The learning rate of only 0.001 with 30% of dropout to avoid overfitting. We use Adam optimizer and cross entropy as a loss. So to see if the performance makes sense, we try with uncertainty quantification. What it means is we do some sampling of the data and then plug it in our neural network so that we can predict to have the lower percent and upper percent type of it. The second question is the factors associated with the disease. So in this case, we assume that if the feature impact a lot to the performance of the model, if it hurt the performance or it make the performance gain so much, so it means the feature is so much important in this case. So the more important of the feature, the more influence of it to the performance of our prediction model. And therefore, we use perturbation of the features, remove one at a time, for example, and then see how it influences the performance. And to discover the size of recovery, we look for a set-based pattern extraction. So the time series is divided into a small time windows and then see what shape represent that time series. So if it maximally represent it, it considered as that the key pattern to tell the state of the patient. So that's how it was done. So in this case, it also be used with using the distance between the set and then the loss function is a difference between the predicted one and the actual one here. So overall, firstly with the disease state classification, and this is the confusion metric. So we can see that the lighter color, it represents a lower value and the darker one represent higher value. So there are more light background for misclassification. And overall, it worked very well with in the model here. So very light here, our model. The misclassification part is very few. On the other hand, other model, it's still showing a dark color on misclassification. That means a higher error rate. So I talk about the uncertainty quantification. So this is the demonstration of that. So each of the state here has the boundary box to tell how much it go into the 95 percentile. And in most of the cases, the correct prediction, if so, most of the time it go into the correct predicted class. About the factors influence to the disease. So in this case, I mentioned it. It is a heart rate variability, and then it has some other feature like the frequency of the signals sent to the patient. So if you can see this diagram, the shorter it means it less influence. So for the mild case, number of days after symptoms onset has a big impact to the stage. And then if we go to the moderate, we can see the rest rate, how much time our heart stop beating, it impact more. You can see that. And then to the severe case, total power, this is the power of the signal, it becomes much more important. So these features show that depending on each of the state, we need to look into different feature in order to measure that, to measure the state of the patient. So about recover severe patient and mild patient. So we want to compare what's the difference between the mild patient and the severe patient. So this is a comparison using the three important time series, which is a total power, the mean rest rate, and the PNN 50. So these signals so that they look very similar initially. So minus 2.5 and 0 is the day from onset symptoms, and this is the time before that. So they look similar initially, and then they start to have diverse, they have two different directions between the mild and the severe case. The severe case make the total power going up. On the other hand, the mild case will just fluctuate and it stabilize there. The same with the rest rate and also PNN 50. So based on this, based on this, we can verify that. So you remember in the past, CDC mentioned to stay at home for 14 days of quarantine. And this data also reflect it will show some differences at 12.5 days. And then, of course, on the day of 14, I believe it will be a clear distinction between the two cases, and that perhaps the reason CDC decided to have 14 days of quarantine. Sign of recovery. So as said, we look at the patterns to represent the state of the patient. So in this case, there are three signals we look into: the rest rate, the deviation, and the deviation from the mean. So patient 187, all of these recovery phones, that means not recover. So we see that there is a pattern showing decreasing trend of the rest rate for the recovery case, while increasing for non-recovery case. Secondly, it looked like a concave parabol for the DI one. So concave, which is like this. And then it looked like a gradually decreasing for recovery, while it non-recovery for the convex parabola shape for the DM signal here. So overall, through this pattern, perhaps it tells the state of the patient, and doctor may look into this as clinical a factor to decide whether the patient will be hospitalized or will stay at home. So this paper is released in Frontier in Big Data in the section of medicine and public health. Okay, so I think I still have time. So the last one I like to share, which is very exciting. So this is again utilizing social media data to deal with emotional health and climate change related structure. Remember that when I go to Google, I type climate change and mental health. So I see there are more than 3 million results. So that means there is some connection between the climate change and mental health. And this is one of the work we try to explore what are the stressors during disaster time. So in this study, with the Hurricane Harvey, we know it's a very big one in Houston, 190 billion in damage of infrastructure, 780,000 people register for assistance, 10,000 people trapped, rescued. So many of the website established to provide support. So this work is a pilot work, it's not fully complete, but the process is like this. From the data, going through cleaning and then emotion prediction. So we know what kind of emotion is going on there. And then we extract the topics discussed on social network using LDA algorithm. And then we have to optimize the number of topics to make sure that it makes sense. And then we annotate the topic because through the annotation, we will know what are the factors people are experiencing or influencing, or so-called the stressor that people are experiencing. So with emotion prediction, we borrow emotion robot dataset, and this model is to predict what kind of emotion people have from chatting, from social media platform. This algorithm is a transfer learning technique. It was trained with 58,000 Reddit comment for 28 different emotion. So this is the process for stressor extraction. From the data set, we do the LDA topic modeling, and then it will show the topic as indicated here. And then on the right-hand side, it will show the distribution of the word. What are the words strongly associated with the topic, and what are the words have less connection with the topic. So we will pick the top, I think in the top maybe 20 words to make sure they are the important one. the last important one, we just throw it away. To find the optimal number of topics, and we know that LDA need to provide number of topics. So we use UMass coherence score. So that means if the tree talk about something similar with each other, the score will be high. So if all the three topic talk about the same thing, so it most likely they discuss the same topic. So the coherence score will help us using the elbow method here. We keep increasing the number of topic until it stabilizes. So we will pick the best number of topic at the elbow like this. So overall, the data set with 400,000 tweets, and then do the stop word remover, any link and special character. And we use TF-IDF to factorize the tweet. And this is the result of emotion distribution. We can see that a lot of emotion happen during the disaster time. And this is more obvious one, starting from the hurricane when it not arrived yet, and then until it arrived, we see a bump of emotion here. And once the hurricane fade out, the emotion reducing that. So that clearly say emotion, I mean, the disaster impact to the emotion of population. A little bit we treat sound out from, so because the emotion, we group it to the stressing emotion. Usually it make, I mean, these emotions show people hurting due to the hurricane. So people discuss more like it happened to their sleep, happened with the building or any destructive. So those are the keyword for the stretching emotion tree. And then this is the number of topic optimized through the coherence score. And we realize that at 55 here, the coherence score doesn't increase much. So we just stop at 55 topics. So once this number of topic is identified, it go to LDA, and then as said, it need to be annotated manually with a topic. So 55 topic is quite easy. We have graduate student to agree on the name of the structure, and then the right hand side are the important terms that we read through it, and we define, we do the annotation. So there are many stressors here. The care of family and friends, they are stressor to them. So that makes sense. We really care about what happening to our family or relative, friend. Landfall danger, closure of business, closure of grocery would be another issue people are facing. Power, safety update, being updated with safety information becomes important. Or any fake news is another part that also a question throughout the disaster here. And here is another list of stressors that we find out. And then it's very funny, we found some alligator escape, and then it make people scared. So this is a pilot project again, and it is still ongoing. We look into more comprehensive category of climate change related structure and supporting vocabularies by going through multiple disaster and multiple disaster type, so that it helps us to bring more comprehensive category of the structure as well as the vocabulary. In this way, it helps us to do more automation to identify the structure through the vocabulary that we can build out. And then we look into how to quantify the emotion and the structure, because one day we like to build this as emotional vulnerability index. It's similar to SVI, but this to tell, or so SVI tell how much you need to support the I mean to support the cell, but EVI care more with emotion aspect of the individual. So if this project is successful, it will be very, it make one step moving forward to care not only with individual physical awareness, but also the emotional awareness. And of course, it becomes a predictor for many public health concerns, include the mental health or public policy to the EVI and the population awareness. So overall, public health is a major concern, especially under climate change circumstances, and wearable and social media data. They are novel and great studying resources for us, and big data algorithm so promising solution and fighting for that. And obviously there are health impact due to climate change, and this topic is very exciting to explore. And nowadays we see with large model, ChatGPT or foundation model. So hopefully it shorten the gap, but I believe it open new research problems, and many of the problem has been identified and under research in our group. So this is different. And last but not least, I'd like to thank the students and from Meharry, from other institution, my collaborator as well, and of course the support from SARS and NSF and NIH to make the work feasible. And thank you so much. And yeah, I'm ready for any question.
Thank you, Dr. Long, for a very interesting talk. And I really liked all the projects that you have explained. I will go ahead with one question, and then I will proceed with the audience to ask questions. So in your project for the opioid relapse prediction, you said you have used GAN, right? So
Right.
what did you use GAN for? Like, did you use it to generate the data or for the predictions? Yeah.
Oh, so that very good question. So remember, GAN has two components. One is a generator and second is a discriminator. And the beauty of GAN is a generator utilizes noise in order to generate similar images. And then it supports the discriminator to identify whether it's fake or it's the real one. So GAN has two purposes that I use here. After throwing the noise to the generator, I utilize a discriminator in order to classify the patient, whether it addict or relapse, relapse, non-relapse, and the fake data. So GAN is used to predict the patient, whether it relapse, non-relapse, and not. And the generator is to improve the generalization of our prediction model.
Okay.
Yeah.
Thank you very much. Is there anyone from the audience?
Yeah. So I want to congratulate you, Dr. Bujing. I'm Benji, and yeah, I really like all of your exposed project and the directions that everything is going on and how you have worked. So just keeping on the same line as Dr. Vibhuti Gupta was asking about the last prediction on your first proceeding that you exposed, you mentioned that you implemented GAN, right? So have you ever reconsidered to, because that is another computational technique that become available after that is cycle GAN. Have you ever considered to implement cycle GAN?
Right. That's a very good question. So first of all, we plot the GAN and then later on cycle GAN come out. So this project is quite like behind when it come out, and And of course, that's very exciting to continue and explore if CycleGAN has a major impact to the performance of it. I believe it should be. It just like it come out just after our work is released. Yeah.
Yeah, I totally agree with that point of
Yeah.
view. So one more
Thank you so
question,
much.
and
Yeah.
so thank you for that, for clarifying that. And in the second one related to the wearables and making prediction in there. So did you mention about R? You know, it's what RR abbreviation means?
Rest rate. So that means
Rest rate. Okay.
how much time our heart stop beating. So usually it beat, I think it 60 seconds or so. I mean, I forgot, but I mean, some second it beat again. But if we make the scale at millisecond, we will see that the heart stop beating and then it beat again. So the rest rate is to tell how much time it stop beating.
Okay. Thank you very much for the clarifying. I think that by creating the architecture of DNN plus LSTM, you know, it was a really good design, you know, implementation of virtual agents.
Yeah.
That's everything from my side.
Okay, thank you.
Thank you. Is there any other question? I think we got a question on chat. Okay, so where do you see the future going with similar implementation or tool?
So okay, so thank you, Ernest, for the question. Well, of course, they are it's still ongoing with a different proposal of the algorithm to improve the existing one, and sometimes it context based. So what I mean here is there may be a better algorithm, but it's specific or certain case. For example, in the wearable data, so this combined with the attribute stream and the temporal stream. So it's a little bit unique, and we have to combine two way of modeling in order to address it. So, and of course, there may be improvement for temporal stream, and then we can try attempt to plug it in to see whether it would work or it would improve the overall performance of the whole model. So yes, it's open for improvement, but be aware of the context of the application. We don't have to look at the new one without caring what is our specific setting. So that's how I would look at it.